Good morning, students. Today we will discuss the model number 4. There are two parts in the model number 4. The first part is data and analytics for IoT, and second part is securing the IoT devices. So, as the first part comes to that, we have to see that what are the different types of algorithms available for analysis purpose, and second part is all about how we can secure the IoT devices and IoT data. So you know that IoT having installed so many sensors, these sensors sense continuously to generate the huge number of data. So that we call as a big data. So to manage these big data is not possible through the traditional database management system like DBMS, Oracle, MySQL, and other things. So we need some special and powerful algorithms to maintain and manage these data. So as you know that the IoT used in a very critical applications like healthcare and autonomous cars. So we need a faster response. So this is all possible through only the strong and powerful algorithms like big data analytics algorithm. So the content of the part 1 of model number 4 is the data and analytics for IoT, then introduction to data analytics, and what is the role of the machine learning in the analytics for IoT, and what are the tools and technologies available for the IoT, and edge streaming analytics and network analytics. So edge streaming analytics means we have to do the processing at the edge only, so that we call as analytics, and we need some network analysis to see that the communication should be happen properly. So these are all the content of the part 1 of the model number 4. The first part contains the sections like what is the importance of analytics, why we need, what are the different types of data available, and so on. Introduction to analytics. So why we need analytics? Because IoT is used in the very critical applications like healthcare, aircraft, and other applications. So if you see the aircraft as an example, there are 5,000 sensors in single aircraft engine. So these sensors will sense the different behavior and working principle of the all the parts of the engine. So there is chances that there may be nearly 10 GB of data will be generated at the per second for one engine. So per day it may generate around 500 TB of data if you consider the aircraft is running for 8 hours with two engines. Okay, so what are the issues here? The first issue is the data transfer, second one is data management. So what is the data transfer means? We need to transfer data from that IoT to the fog computing with the cloud computing for analysis purpose. So some analysis will done at the edge level, some analysis done at the fog level, some analysis are done at the cloud level. So we need huge number of bandwidth to transfer these huge number of data. So that is the first issue. Second issue is to manage the data, to store it, to access this data efficiently. We need some strong algorithms. So that is another issue of data management. Another example, like we have seen that smart metering, where we can install the smart metering at each and every household or each and every home. So what is the main task of these smart metering? It's going to calculate that amount or price based on the energy consumption in your home. So we are nearly having for one city there may be chance of 50,000 families are available. So 50,000 smart meters we require, and each one smart meter may have this 5 to 6 sensors. So all around, if you see that for one city, small city, so we require around uh, lakhs together sensors. So these sensors will sense data, and these data should be processed and do analysis on this data. So how much that energy is consumed, what is the amount has to be come to the electrical grid. So these are all the other part. Now we'll see that what is the difference between structured and unstructured data. So structured data means these all are organized data, it's having in a particular format. Unstructured means they don't have any particular format, there is a randomness in the data, so that we call as an unstructured data. So if you take an example of database, that is row and column in a tabular way, that is also one of the example of organizing our structured data. Another one is spreadsheets. Spreadsheet means your Excel sheets, that also use considered as a structured data. And unstructured means your text, random text, images, video, and speech or voice. These are also unstructured data. There is no proper format for this structure. these data, so we call this as unstructured data. Now if you think that most of the times in IoT we combination of both data, like structured as well as unstructured data. So which one is easy to maintain, which one is difficult to maintain, we'll see. The structured data is easy to display, it can take very less number of storage, and it's having its own format, so it is easier to manage. For unstructured data, we can't display the data in the row and column terms like database, and these contains only images, audios and videos, some randomness in the all the type of data, and it requires more storage, because if you see the video and audio and images, they always take the more storage, and it's very difficult to manage because accessing these data and storing these data require strong algorithms, so it is a little bit difficult to manage the unstructured. And the third category is combination of both structured data and unstructured data, where we are going to combine these together to frame the particular semi-structured data. There are two examples here. We can see that email is a good example of semi-structured data, where we are having certain fields like to whom you want to send the mail, and what is the CC, BCC, and what is attachment and subject. So these are all having some structure. But unstructured means the content of the mail is an unstructured data. So that may be mail body may be having some images, audios and videos also. So that is a good example of semi-structured data. Another example are JSON and XML, because the data may be a certain format, but the content of the data is not in a particular format, so we treat this as a semi-structured data. Now, so what is the difference between data in motion, data at the rest? The only simple difference is the whatever data stored in the particular storage devices is called an data at the rest. Data in transit we call it the data in motion, because always if you see the IoT environment, data is moving from the one location to other location, from sensor to edge, edge to gateway, gateway to fog, fog to cloud, like that. So this data is called as an data in motion or data in transit. So most of the times the data in transit always will be processed, filtered, aggregated to do the to increase the efficiency of the data. Now whatever the data in the motion is dynamic, and data at the rest is static. So most of data is available at the data centers, and edge is a data in motion. The stored data in a storage device is called an data at the rest. Then next come to second topic, where we have to see that what is the overview of the data analytics things, what different types of algorithms available, what are the layers, and what are the different data collection or different types of sensors we can have. There are three layers here. The first layer is we are having the algorithm, that is the data analytics algorithm. Second one is about big data technologies, where we can apply that these technologies to collect, process, aggregate and visualize the data. And the last third layer is called data layer, where we can generate the data from various devices, various media and various levels. So these are three levels. So if you consider first layer is analysis layer, there are three types of analysis. There are four types of analysis. The first one is descriptive, means what exactly it is, what is happening here, and diagnostic. So why it is data look like, why data is coming like this. So that is called diagnostic. We can analyze that based on descriptive data. We can come to know that so this is happening. So like that. Then the third one is predictive data. So what happened in future, so what is the load of the system at the next time time stop. So after that, prescriptive, why should I do about it. So if something is going to wrong in the system, what can I take the action, that's called prescriptive analysis. So second level comes to that big data technologies. There are certain algorithms are available for each and every phase. Whenever you go for analysis, they always the first phase is you have to collect the data. Second one is you can have to filter it, aggregate it, and process it. At the end, you can give the results in terms of graphs, in terms of any data or as a log files. And last layer is all about that how we can generate the data, how can we match the data, how can we get the data, how can we process the data. So it may be EDO, audio, geographic locations, so many data are available, we can have the unstructured and structured data in this layer. Now we'll see that data complexity versus its value. So whenever that descriptive data is having less value and it's less complexity, and like that, if you see that the graph shows that, so the descriptive analysis always have the more complexity and it's having more value. Why it is more value means what action I have to perform to improve the performance. That is very important in the all the aspects of either it's a cloud computing, fog computing, or edge computing. What are the challenges of digital analytics? There are mainly two challenges. There are so many challenges are available, but we'll only concentrate on the important challenges in this topic. The first one is scalability issue. Whenever the number of IoT devices or sensor increases, how can I able to manage this data? And second challenge is volatile data means always data is changing from that one level to another level, like edge to fog, fog to cloud, and in between while processing data is dimension of data is going to change. So how can we can manage these two challenges? Okay, and solve these two challenges. There are so many solutions are here. The first one is we have to use the NoSQL, as we already learned in the BDA. What is the use of NoSQL and how we can stream the data with filtering. So while streaming only we have to filter the data, we have to remove the unwanted data. So that is we call as streaming data with the filtering. And last one is network analytics. We have to see that, we have to analyze the network, communication aspects, you have to manage, monitor, and see the security aspects of network. Then based on that, these monitored values, monitor decision, we have to take the communication between edge to fog, fog to cloud. And then the third topic is all about that what is the role of machine learning in the big data analytics. So there are so many algorithms available in the machine learning that you use for the analysis purpose. The first one is supervised, unsupervised learning. So there are mainly four categories: supervised, unsupervised, reinforcement, and semi-supervised learning. So based on the problem requirement, so we have to go with the particular algorithm. Then the main important architecture in machine learning is neural network learning. So where we have to build the network of layers. So one, some are the input layer, some are output layer, and some are hidden layer. So we have to give the input from the input layer and it will process in the hidden layer and give the output at the output layer. So if you see the case study of to recognize the animal dog or wolf, so you have to train the model first. First you have to see that what is the characteristics of dog. You have to train to the neural network. Based on that you have to give the image of either dog or wolf. Based on the learning in the network, you're going to give the result of whether the animal is dog or wolf. Machine learning and getting intelligent in the from big data. Okay, so there are two main categories in the machine learning. The first one is local learning, other one is remote learning. So local learning is data is collected and processed locally in the edge itself or in the gateway in the fog. And remote learning means we have to send this data to the cloud where the central device is going to take the processing task in the cloud only. But main problem is local learning having its own problem, remote learning also having its own problem. Local learning means we don't have the so much infrastructure or so much computation power to calculate the to compute the uh, machine learning algorithms. And if you consider remote learning, so main problem is latency. So that is the biggest issue in the remote learning, wherever we are having so many of data, so many processing capabilities, so like cloud. So sending the data to the cloud and getting the response back from the cloud is very biggest challenge. So again it depends upon the requirement. You can go for the either of local learning or remote. So ML application, that's machine learning application for IoT. So already you have learned all these things in the previous semester. What is the machine learning, what are its application, different types of algorithms, different types of techniques. Okay, so main advanced application is predictive. So what happen in future if I'm having these data based on the historical data, we can imagine or we can predict the future of the future status of the system. So next topic is all about that big data analytics tools and technology. So I will not go in detail about this one because already you learned in the same semester, in their semester only, we learned about that BDA. So if you don't know anything apart from whatever you having in the syllabus, you can post into the forum. So I am going to resolve your issues or problems. So there are so many algorithms or technology available for BDA. So what is BDA? BDA is all about the different types of data that's coming from the different types of locations. So that can be huge data, different types of data. It may be semi-structured, structured, or unstructured data. So there are three important characteristics, three V's we call as the velocity, variety, and volume. Velocity means the data is going to volatile, means we are going to change each every time, so it's called velocity. Variety means we can have different types of data like maybe text, image, audio, video. So many data is called variety. Then volume means the data scale of data is very huge. So in terms of TB we are having the data, so we need to analyze these data together with the three V's. Okay, so what are the characteristics of big data? So it's all about the machine data. The data is generated from the machine. It may be structured or unstructured. Most of the time it's the unstructured, because machine don't know the structured way to generate the data. So we need to do the programming on the machine to get into the structured data. Then transactional data means data in transit or processed data. And social data sources. So what is a social data means? So it's a high volume and it's a structured data. For example, you see the Facebook, most of the times it's called as a combination of both, but it's high volume as well as it's having some part of structured data. And last one is enterprise. So whatever you using these data is used for the enterprise purpose or business purpose. So what are the phases of the big BDA? The first one, you have to take the data from the different sensor, different IoT devices. Then you have to remove unwanted data, that we call as a filtering. After filtering, you have to summarize the data based on some predefined or built-in functions, aggregation function. And last one, based on these all the data, whatever aggregated, you have to do some analysis on that and you have to give the result in terms of graphs, in terms of any decisions. The next part is massive parallel processing database. So apart from this BDA, we're having one more concept about parallel processing in database. So these are very strongest or much faster, efficient databases that can run the query within a fraction of seconds, a fraction of milliseconds. Also, we can also call. So they're having some predefined analytical functions. You can use it for fast processing, and all the data, massive data, will be executed in parallel, because the massively parallel processing database having the strong infrastructure, multi-processor, multi-level, multitasking concept is going to apply, so that it's very faster in the response. So this is a MPP architecture, that is a shared thing architecture. Means that there are some masters, some are segment host. Master role is to control the all the components in the architecture, and we're having one more master called standby master. So standby master means if some master node is going to fail at that time, you have to use the standby master. So meaning that it's a fault tolerance technique. Whenever something is going wrong with the master host, that control is going to taken by the standby master. So each and every node having its own infrastructure, CPU, RAM, as well as database, along with some processing capabilities like algorithms. Next one is NoSQL database. So already you learn about this one, but the thing is that NoSQL means doesn't have any structure here. It may have the different types of data like XML, JSON. It may have the associated arrays also. It may have the column wise also. It may store in the graphs in the database also. So different types of data is going to store in the database, that we call as the NoSQL database. So first is XML, JSON, associative array, rows and columns like a table or tabular, and last one is graphs. So NoSQL going to store all these different types of data in the database. So other part is Hadoop. Hadoop is mainly one architecture where we can use for the parallel processing as well as faster processing. So it contains the file system like distributed file system, that is SDFS. Along with that, we are having that one more concept is MapReduce. So MapReduce is going to map the data for a particular problem or particular solution. Once you get the map the problem, you can apply the reduce operations to solve that problem. So apart from this, we are having so many tools available: yarn, Apache Kafka, Spark, Storm, and Flink. And last one is Lambda architecture. So these are also used for the big data tools and big data analytics. So these are the tools and technologies for the BDE. So next one is edge streaming analytics. So it's all about that processing all the data and get the analytic results at the edge only. So IoT generates huge number of data, so it is not possible to process all the data at the edge only. So some important or high priority data should be processed at the edge, and low priority processor will be sent to the cloud. If you take the Formula One racing example, so each car may have around 150 to 200 sensors. They will generate the more data at per second. So maintaining or processing all these data at a small amount of time is very difficult. But still, based on the requirement, we have to have the our own infrastructure. So what is the use of this analytics in the Formula One racing? So we have to, it has to some sense have to understand that whether the air in the tire is correct or not always. So when to go to the garage, maintenance garage, when to pass it, and when to change the tire. So many things are available. So it's all depends on the how the sensors is going to sense the data and give the result to the driver. Then comparing big data with the edge analytics. So both will be processed used for analytics only, but big data is processed at the cloud and edge analytics will process at the edge. Okay. So as you know that if it is processed at the cloud, we require more bandwidth and it's not suitable for the time sensitive applications. But edge analytics is having less infrastructure, but it is consume less bandwidth, as well as it's suitable for the time sensitive applications. Then if you already you know that the cloud will take the more delay and the edge will take the very less delay, because we are not sending any data to the cloud itself, so that is going to take the lesser delay. And next part is streaming analytics has a less value in the business, because if the delay is more, these applications will not have the business perspective. So that whenever you have the time critical applications are running more in the business compared to the non critical times, means not non time sensitive applications. And BDA is more secure compared to the edge analytics, because the data is stored in the cloud is having its own fine infrastructure to secure the data, but edge don't have infrastructure to maintain the security in the data. To summarize all the things, main thing is to reducing the data at the edge. So what is the first task is to, if you go for the edge analytics, I must reduce the data and analyze and response at the edge. So once the data is collected, it should be filtered and it should be do the analysis, and then only you will get the good results from the edge analytics. And the edge analytics is used only for the time sensitive applications. Now what are the functions, predefined or core functions here? The whole analytics will be divided into three simple stages. The first one is raw input data, second one is the analytics processing unit, third one is output stream. So first one is all about collecting data, second is all about how to process data, third one is how to give the results to the data to other parts of the unit. So this is a pictorial representation of how the edge analytics will work. The first one is how the raw data is streaming towards to the edge and edge to the edge. Edge is having its own infrastructure like storage, processing, and other stuff. Then once it is processed, it will give the result in terms of formatted or structured data. Now what is the analytical processing unit functions? So as we know that from the first slide, we can see that it may have the first I have to collect the data. So data collection is the input part. After collecting data, I need to remove the unwanted data, and if possible I need to aggregate data in a summarized way or in a short form. Then after the filtering, I have to go for the formatting. I have some tools like ETL, that is the extract, transfer and load technology, that mainly used for the testing purpose, and other areas also it can be used. But thing is that it mainly used for the transformation from high multi-dimensional data to the single dimensional data, or it may assume that making the data to very simple form, that we call an formatting or ETL. Then other function is we have to aggregate the data based on the time. So what means that when in one application, in one aircraft engine, there are so many sensors are there. So continuously these sensors send data to the master node or controller. So it's very difficult to get the data from these sensors and store in a form to do the directly we send to the analysis. Before that, we need to have some formatting that aggregate the data based on the time. If I take the temperature, so temperature sensors always sense the temperature in a second wise or millisecond wise. But thing is that I need to take that. You should not necessarily take all the values. You should take that only per minute or 5 minutes. What is the temperature for last 5 minutes? So like that, we have to aggregate the data. We'll see the one figure in the next slide. Then correlate. After combining all this data, after collecting all this data, so what is I have to come to the one conclusion that what is the present status of the system. If I take the real-time example about the patient, if the patient is having so many sensors in the hospital like heartbeat, BP, sugar, so many sensors are there. Based on this data, I can come to the conclusion that patient is having certain disease like this. He may have the disease like this because for that disease I have to give the solution. So that comes in the next second part, that's called pattern matching. So based on the historical data, based on the previous patient's condition, how you given the solution for that, whether that solution work properly or not. So if it is work properly, you have to apply for that pattern to the next coming patient to give the to diagnose the disease and to resolve his problems as well as problem as well as possible. So last one is if it is overall thing is going to happen properly, again it will go for the business intelligence because business intelligence always require the execute the all the analytics functions, all the core functions at a very short period of time. Then only it's go for the business. Otherwise, it's very difficult to go for the business intelligence. So once you put all these things into the business, automatically your business will be improved. So automatically you will get a more profit. So this is an example of how we can aggregate the data at that particular time stamp. So there are how many five or three sensors here: sensor 5, sensor 3, sensor 2. So like that. So now if you see that after aggregation only sensor 5 data is coming into the picture here, then sensor 3 data, sensor 2 data like this. So based on the criteria whether I'm going for the sensor wise or going for the value wise. So like that we have to see the aggregation. This is all about that how we are going to correlate the data. Once I have collected data, I have to filter it, then I have to reduce it to make it to simple form, then I have to correlate with the historical data. So if I assume that BP and heartbeat, so we can it may leads to the heart stroke also. Before only that, if I want to take that heart stroke, I have to take some actions and diagnose the disease as early as possible to give the more good treatment to the patient. And next part is distributed analytics system. So where the process will be done distributed toward the different nodes in the network. So that we call it the distributed analytics system. So here we are having certain brokers here. The broker task is to transfer data from one location to another location, or may allocate some resources, or may take some decision to that. So how can the work should be data should be flow between one layer to the another layer. So there are three important parts here: edge location, processing platforms like fog location, and last one is cloud location. So at the edge, what happened that the different sensors are there. They are going to sense the data and pass data to the broker. Broker will send the data to the higher level, that is the fog level. So where we can do the possible analysis in the fog itself. If it's not possible, we can send to the cloud. So like that, the every analytic system, electrical work will be distributed throughout the three different layers. Either it's at the edge level, processing level, and at the data center level. And the last topic, that's about that network analytics. So network analytics is all about the discovering the certain patterns in the communication flow of the network. It may be traffic, it may be jitter, it may be certain conditions of the network. So we need to analyze that these status of the network that we call as a network analysis. So this may have the certain properties. The first task of properties to analyze the details of the communication patterns made by the protocols and correlate this across the network. There are some communication details like what is the bandwidth, what is the capacity, and what is the speed, what is the type of cable or type of medium you are using. So we need to analyze all this data. So which is having more idle means which is having less traffic, then that communication network I have to choose. So for that purpose I need to have the network analytics. Other other advantage is that I can understand the behavior of the network. So what are the different anomalies may occur in the particular path or particular network? If there are possibilities that someone has intrusion can malware the system or can be congestive. So this is all for that smoothly running that the communication between different layers of the IoT environment, maybe edge, fog, and cloud. So what are the functions of the network analytics? The first one is network traffic monitoring and profiling. So you need to monitor the traffic of the network. Whether the traffic is very congested in a particular area, that you have to analyze why it is congested, what are the troubleshooting techniques I can apply to reduce that traffic. That's all about that first part. Application traffic. So the particular application having its own capacity. If so many users are accessing the same application at the same time, it's very difficult to manage that application. So for that we need to analyze the traffic monitoring of that particular application. Next one is capacity planning. So we need to plan in advance about that how we can allocate the resources when they based on certain statuses, like when it is an cloud status or fog status is under the load, means it's under load, then we can have certain planning. If it is a intermediate load, certain planning you have to apply for the intermediate. When it's a heavy load, then you have to take care of that, how much I have to allocate, deallocate or relocate the processes. Next one is about security. Is there any security means threats available in the particular network that you have to monitor? Next one is about accounting. How many users are using, how many, which user uses the this, what type of network, how much bandwidth is used, that will be taken by that accounting. And last one is data harvesting and mining. So we have to see that details about the particular network with respect to user, with respect to resources, with respect to performance. So like that we have to use the network analytics. So this is a small example. There is a grid example, smart grid example, where I am going to use the FAN. That is a PDD network. So that is limited to the certain area. So maybe in the one city, like that I have to use it. So multi-service FAN means multi-service PDD network, that maybe have more than one services is possible to use from that FAN. So we are having SCADA architecture, where we can have that certain resources where to process, where that particular processing is going to takes place. Then network operator management. So we're going to see the different types of network operators, network providers. So what they are using for allocation of the network, allocation of the resources, maybe security and about encryption and all about network management. So everything will be happen in between about the intelligent routers or intelligent gateways. So along with that we are having some firewall here. The firewall is over filter the unwanted data and remove from the system. And flexible NetFlow architecture is one of the famous architecture that is developed by Cisco, that are widely used all over the world to monitor the network application. So what are the advantages? Why we use it? So it's very flexible, scalable, and aggregation flow of data means as more number of IoT devices increases, it may have able to handle the large number of devices. Ability to monitor wide range of packet information. So in one network there are so many millions or billions of networks packets are going to route from one location to another location. So you have to able to monitor the all the packet information and produce new information based on this analysis. So that is possible with the FNF. Enhanced network anomaly and security detection. It's also good for the detecting the anomalies and detecting the security threats. Then user can configure based on the particular traffic identification. So he can configure the how much bandwidth he required, how much capacity he required, how much resources he required. He can do all the configuration as the user end only. Then last one is convergence of multiple account technologies into one accounting mechanism. So it's all about that accounting, how many users are using that system, so at the same time, what is the what resource is used, how much data is processed, how much data is transferred from one location to another location, all information available in that. Then this is very important about that FNF components. So these components are very helpful for the monitoring or processing the communication packets. The first one is cache. We should have the cache because we need to store the recent items that we call as a flow monitor. So now we have to understand that what is the flow of the data, flow of the packets, flow of the records in the system. Then FNF exporter means that will going to export some data to the higher end. Then it's having some timers where we can manage that. We take it based on the timers. It's going to collect the data and have some analysis. Then server collection and reporting. So server collection means it's going to collect some information and report to the users. So this is a graph that generated by the FNF components. So it may have the what is the traffic of the particular server, particular SCADA server, but what is the meter reads, meter, and what is the minimum bandwidth, maximum bandwidth, delay. So all things will come into the picture. So can I use this NetFlow in a multi-service architecture? Probably not, because in a multi-service architecture it's very difficult to manage all the services. So multiple services should be run at the parallel and it's very difficult. But still I can use it when we are having this limited services. So what are the issues, challenges in this? The first one is combination of IPv4 and IPv6. So very difficult to manage that whenever we're having the both type of internet protocols. So it may be used to tunneling and you have to identify the router performance is very difficult here. And its distributed nature of fog and edge computing may mean that traffic flows are processed in the place that might not support the flow analytics. At some levels like fog, edge, they are very resource constrained. It's very difficult to take the analysis at the particular level. And third one is all about that management network traffic. Managing network having very difficult when you are having that multiple services. If all the services are high priority, then it's very difficult to manage. Some are low, some are high, then only it is able to manage the all the information, all the communication aspects